exercise 10 of chapter 5 is actually a follow-up, like an extension of exercise 3 in chapter 3. So there we were discussing how to simulate or how to image a two-dimensional vector subspace that is defined by two vectors in R3. So two linearly independent vectors in R3. You might remember this with the dots in the plane and plotly. I'm going to show you that code in a moment. Okay, there we were using vector scalar operations, and here now in this chapter, exercise 10, we are going to be using matrix vector multiplication instead of vector scalar multiplication. So you'll remember that in exercise 3 of chapter 3, we multiplied sigma 1 times v1 plus sigma 2 times v2. And now what we are going to do is multiply a times s. You can see it's much more elegant. This is a much more appropriate and scalable method. So the columns of matrix A would be the vectors v1 and v2, and S would be a vector that contains the two elements sigma 1 and sigma 2. So let me begin here by showing you the code from chapter 3. This is not the code for chapter 5. This is the code for chapter 3, exercise 3, just as a reminder. So we had these two separate vectors, and then in a for loop, we were saying we're coming up with these random scalars and then multiplying v1 times the first scalar plus v2 times the second scalar. And you might remember, let me zoom in here, that created this series of dots here, and it all lies on a plane. Okay, so that is the concept that we are going to reproduce. Now here we are in the code file for chapter 5, exercise 10. So now you can see that I'm defining a matrix. It has 3 rows and 2 columns, and this column corresponds to v1, this column corresponds to v2. I'm again creating this matrix of scalars, but now here I am doing implementing matrix vector multiplication. So instead of writing out v1 s1 plus v2 s2, I'm just writing out a times this particular row of this scalars matrix. So each row in this matrix is a vector. Okay, so I think you can see this is more elegant, but it's also more compact. It's also more scalable. So we can now very easily scale this up to any arbitrary number of dimensions that we want. Okay, otherwise, a lot of this code is the same. If you have gotten through the Plotly code from chapter 3, then you'll recognize a lot of this code. Okay, and then I also used bigger purple dots here instead of smaller black dots, but the principle is the same. The idea is that we are visualizing a finite number of points out of, a sample of an infinite number of points on this two-dimensional vector space. And let's see, you can also uncomment this line. This basically, you'll remember from chapter 3. We could follow up with these vectors by setting the second vector be 1/2 of the first vector. So you can also just uncomment this to confirm that that's going to give us a line in 3D instead of a two-dimensional plane.